Hello. Welcome to the final review problem. So this is problem 3. This is going to be an oligopoly model. So we're going to have multiple firms that are competing. We're going to first consider price competition, where the firms are setting prices for a homogeneous good. Then we'll see what the equilibrium is there. Then we're going to consider quantity competition. So this is Cournot competition. We're going to assume firms are competing in quantities, and we'll see a different result here. And then we're going to, instead of just looking at 2 firms, we're going to have 4 firms. So this is going to change a little bit, but it's going to be the same structure as this one. So we're just going to add 2 more firms. And then finally, what we're going to do is we're going to consider a differentiated Bertrand game. So the products are not going to be the same. There's going to be some difference between them. People will substitute accordingly. So we'll get into what all that means in a second, but I'm just going to start out writing out the demand function. So for part A, we have QD is 1500 minus 20p. Okay, so there are 2 firms. See, we have the cost function of each firm. The cost function of each firm is just going to be 10Q. I'm just going to write that. Okay. Now what we're going to do is for part A, we're going to assume firms are selling an identical product. So when we say Bertrand game, and there's no differentiation. See, in part D, they differentiate the products. That tells you that it's a differentiated Bertrand game. Here, it's a Bertrand game. There's no differentiation here. So it's just a homogeneous good, Bertrand. Okay. So what we're going to find here is, well, what we need to do is we need to determine what consumers will do. So okay. What I want to illustrate here, what the key to this type of problem, is that consumers choose to buy from whoever sets the lowest price. So this means if A sets PA equal to 20, B sets PB equal to 19, everyone buys from B. Okay, so firms can undercut each other, and they will get all of the demand in the market. The other firm will get nothing. So what we're going to do is we're going to use this property, and we're going to determine what the best responses of each firm are, and then use that to find the equilibrium. So we're asked in this question, is an equilibrium for firms to set price, like both set prices equal to 30? what am I doing? Okay, so we're asking, is this an equilibrium? Well, in an equilibrium, each player needs to be playing their best response. So is each player best responding to the action taken by their opponent? Well, here, when they're both playing 30-30, they're getting a certain profit. They're splitting the market. But let's see what happens if firm A chooses 30 minus 0.0001. Well, okay, first, when PA is equal to PB is equal to 30, firms split the market evenly. Okay, but PA is equal to 29.9999, repeating. Then A gets all of the demand. So this is, so PA is equal to 30 is not their best response. Okay. So we know that PA equal to PB equal to 30 is not an equilibrium. Okay, so we're going to repeat this analysis when we consider what happens if PA is 20 and PB is 15. Okay, well, are firms best responding? No. Why do I say that? Okay, so to think about why, let's look at what firms are getting. Everyone's currently buying from B. Firm A is getting nothing. Well, firm B could increase their price to 19.999. They would still get all of the market, but they'd be getting more revenue. Or what we could do, or another way that we could argue it is, this means since everyone's buying from B, A is currently getting 0 profits. Now, what if A sets PA equal to 14.9999, repeating. Then A gets all the demand. B gets nothing. So PA is equal to 20 is not a best response. So this means PA, PB equal to 2015 is not. Okay, so we did the first two. Now we want to determine what is a Nash equilibrium here. I've shown you two things which aren't equilibrium, and now we want to find which one is. So I'm going to do it to the side here. Okay, so recall that firms have a marginal cost of 10. So their cost of producing Q is 10Q. So the marginal cost is going to be 10. They will never produce below their marginal cost. Otherwise, they'd be losing money and they would just prefer to shut down. Okay, but we've shown that if one firm sets a price greater than marginal cost, the other firm has an incentive to undercut. See, if price of B is 30, then A can undercut ever so slightly and get all of the demand. And then similarly, if A were to set a price of 30, B could undercut by setting a price of 29.999 and undercut them. So players kind of bid themselves down to their marginal cost. Right? No firm wants to set a price below the marginal cost because they'd be losing money on each unit. This wouldn't be a very profitable strategy. They'd be making negative money. But as long as the other firm is setting a price above 10, this firm has an incentive to undercut. So we can see that for any price above 10, the other firm would have an incentive to undercut, and this drives the price down to the marginal cost. So in this equilibrium, so we'll have PA equal to PB equal to 10. Each firm has no incentive to lower their price because then they would be losing money. And we see here that firms are pricing at marginal cost. Now what we want to find is the quantity. So the quantity is 1500. Just plugging this price into the demand function, it's 1500 minus 20p. So this is 1500 minus 200, also known as 1300, or 1300. So. Okay, and then finally, each firm gets 650. And then we want to find the markup, or the margin. So this is defined as price minus marginal cost divided by price. Here, price is 10, marginal cost is 10, divided by price of 10. This is just 0. This is because firms are pricing at marginal cost. Hello. Okay, so now we're going to do Cournot competition. Sorry for the jump cut. I made a mistake as I was going through this problem, and I realized the mistake as I got almost all the way through, and that is why I'm re-recording this. I erased some of the parts that I will be filling in later, and I left some parts just to give you context, and yeah. So I'm re-recording this, unfortunately. Sometimes it happens. All right, so we're going to be looking at Cournot competitions. This is competition in quantities. Here, each firm will be setting quantities QA and QB respectively. Okay, so just to give you a sense, they're facing this common demand function. Each of them has the same cost technology, and they're setting quantities instead of prices here. Okay, so this is the overall market demand function. What we want to do for this problem, it'll be helpful to find the inverse demand function. So I'm going to rewrite this, and I want to find P as a function of Q. We'll see why in a bit. But what I'm going to do is I'm just going to rearrange this expression right here to solve for P as a function of Q. So I get 20P is 1500 minus Q. So this means that I have P is 1500 divided by 20 minus Q divided by 20. So in other words, P is 75 minus Q over 20. So this is the inverse demand function. What I've done is I've found P as a function of Q, where Q is total market quantity. So this tells us, based on what firms produce, this tells us the price. So the total industry quantity is just going to be the sum of what each firm produces. So it's going to be how much firm A produces plus how much firm B produces. So we're going to add those up together. Now, the game here is that firms are choosing QA and QB strategically to maximize their own profits, given what the other firm is doing. So what we can do here is we can use the tools of game theory. We're going to find a Nash equilibrium in this game, and that'll tell us the equilibrium here. So we're going to find the best response of each firm to a quantity set by the other firm, and this will give us a way of finding the equilibrium. So the way that we do this, the way that we proceed, is we have our inverse demand function, and we're going to express this as a function of what each firm chooses. So I'm going to plug in this total industry quantity into the inverse demand function. So it's going to be 75 minus QA plus QB over 20. So it's going to be 75 minus QA over 20 minus QB over 20. So now we're going to use this to find the profits of firm A of producing QA when firm B produces QB. Okay, so the profit is going to be revenue minus cost. And breaking that down further, it's going to be the price that firm A gets times the quantity they sell minus their cost of producing that quantity. So it's going to be 75 minus QA over 20 minus QB over 20. This is their price. Then we're going to multiply this by the quantity that A produces. This is their quantity. And finally, we're going to subtract off their cost of 10 QA. Okay, so I'm going to write this out just in a simpler form. So it's going to be 75 QA minus QA squared over 20 minus QA QB over 20 minus 10 QA. And I can rewrite this as 65 QA minus QA squared over 20 minus QA QB over 20. Okay, so this is the profit function of firm A. What this tells me is the profit given QA and QB. I want to maximize the profit subject to the choice of firm B. So I'm going to take the derivative with respect to the quantity of firm A and set that derivative equal to 0. That's how I find a maximum. So I'm going to find the quantity of firm A, which sets this derivative equal to 0, which will give me the optimal quantity. So I'm going to take the derivative of firm A's profit function, and I'll set it equal to 0. So that's going to give me 65 minus QA over 10 minus QB over 20. So I'm going to set that equal to 0 to find the maximum. Just going to move this over. So this means that I have QA over 10 is equal to 65 minus QB over 20. Okay, and finally, QA is equal to 650 minus QB over 2. So this is the best response from A to quantity QB. So it's 650 minus QB over 2. So what this is telling us is based on some level of production QB chosen by firm B, this is what firm A should optimally produce. I'm going to erase my previously wrong work down here. Sorry about that. Okay. We all make mistakes. It's important to acknowledge them. Okay, so the profit of firm B is going to be found similarly. So we're going to have 75 minus QB 220 minus QA over 20 times QB minus 10 QB. So this ends up being 65 QB minus QB squared over 20 minus QA QB over 20. This ends up being, when we take the derivative, we get 65 minus QA over 20 minus QB over 10. We're going to set that equal to 0 to find the max. So we get QB is going to be 650 minus QA over 2. Okay, so this gives us the best response of firm B to the quantity set by firm A. Okay, so we found the best response functions. I'm going to color this in green. Now, what we're going to do is we're going to recognize that in equilibrium, we need firms to be best responding to each other. So this means that the equilibrium quantity chosen by firm A has to be their best response to the quantity chosen by firm B. Simultaneously, we need firm B's best response, firm B's quantity to be their best response to the quantity chosen by firm A. So we need these to simultaneously hold. So what we're going to do is we're going to plug one of these best responses into the other. So we're just going to solve this. This is essentially a system of linear equations. We're going to plug one of these functions into the other and then solve for the resulting quantity. So just showing you how I do this here, I'm just going to rewrite it again. So I'm going to say, all right, I'm going to plug QB star into QA star. So plug the best responsive firm B into the best responsive firm A. So it's going to be best responsive firm A So what I'm going to do is I'm saying whatever QA does, whatever A does, this is firm B's best response to that. And then given firm B's best response, this is firm A's best response. So I'm putting one best response inside of the other, and then I'm going to solve for the resulting QA star. Okay, so again, undoing my past mistakes because I'm silly. What I'm going to get is I get QA is going to be 650 minus 650 over 2 plus QA star over 4. Again, there's a minus, there's a minus negative here, so I add, it's a positive. So this gives me 3/4 QA star is equal to 650 over 2. And finally, I get that QA star when I multiply both sides by the reciprocal of 3/4. So I multiply both sides by 4/3. I get QA star is 650 over 2 times 4 over 3. So this is just going to be 650 times 2 over 3, which is also known as 1. So it's 1300 divided by 3. And this is the quantity of firm A. Similarly, for firm B, I'm just going to erase all these. Sorry for the problems here. Okay, sorry for the messiness. So what I'm going to do is I'm going to take this quantity for firm A and find firm B's best response to it. So it is going to be the best response of B to 1300 divided by 3. So this is going to be, it was 650 minus 1300 over 3 divided by 2. So it's 650 minus 1300 divided by 2 times 3. I can rewrite this as 650 minus, so 1300 divided by 2 is going to be 650 divided by 3. So this ends up being 3 times 650, just to find a common denominator. This is 1950 over 3 minus 650 over 3. And that ends up being a nice symmetric 1300 over 3. So equilibrium quantities are 1300 over 3 and 1300 divided by 3. These are the equilibria. Or this is the equilibria. So we're going to use this to solve for the equilibrium price. So the price is 75 minus QA plus QB divided by 20. That's 1300 over 3 plus 1300 divided by 3 divided by 20. So this ends up being 75 minus 2 times 1300 divided by 3 divided by 20. So this is 75 minus 1300 divided by, we get 3 times 10. So 75 minus 1300 divided by 30. Okay, so this is a bit annoying to compute. I think it ends up being 95 over 3. Okay, so this is the equilibrium price. Now we're going to look at the equilibrium margin. So the equilibrium margin is going to be price minus marginal cost divided by price. So here, price was 95 divided by 3 minus marginal cost of 10 divided by 95 divided by 3. So I'm going to find a common denominator on the top. This means I get 95 over 3 minus 30 over 3 divided by 95 over 3. And just simplifying this, I will get 65 over 3 divided by 95 over 3. So that's just 65 over 95. In other words, that's 13 over 19, which is approximately, I think, 68%. Okay, so the equilibrium markups in this case are going to be 68%, or the equilibrium margin is going to be 68%. Okay, so that is part B. Now, we're going to assume there are 4 firms competing. Each of them has the same cost function. Now we're going to find the Nash equilibrium quantities, the total equilibrium quantity and the corresponding equilibrium price. So the way that we do this is going to be similar. It's just going to be a little bit trickier because we have 4 firms now. So what I'm going to do is I'm just going to set up the profit function for firm A. Then I'm going to argue that the profit functions for all the other firms are going to be symmetric and give me the same best responses. I'll show you what I mean in a bit. First, what I'm going to do is I'm going to show you that Q is going to be QA plus QB plus QC plus QD. Okay? And the inverse demand function is 75 minus QA plus QB plus QC plus QD, all divided by 20. Okay. So one thing that will help here is I'm going to consider the profit function of firm A. I'm going to define Q negative A as QB plus QC plus QD. So this is the sum of all competitors' quantities. Of all A's competitors. Okay, so this is the sum of everyone who isn't A. And this is just Q negative A. That's kind of a compact way of saying it. So the profit of firm A, given QA and Q negative A, is going to be the price. It's the price they get. So it's 75 minus QA plus Q negative A divided by 20 times QA minus 10 times QA. Okay, so all I did was I just redefined this term right here. I just called it Q negative A, and I just wrote it like that just to keep things compact. So I'm going to find, I'm just going to simplify this. I'll get, like I did before, 65QA minus QA squared over 20 minus QA Q negative A over 20. So again, just using my new notation, this is just the sum of all competitors. So I want to find the derivative of this and set it equal to 0. So I get 65 minus QA over 10 minus Q negative A over 20. So set this equal to 0. Like I did in the previous part of the problem, I'll get QA is equal to 650 minus Q negative A divided by 20. Divided by 2, sorry. So nothing fundamentally changes about the shape of the best response. The only thing that changes is I have a Q negative A here instead of just a QB. So this is, so the best response of A to quantity Q negative A is going to be 650 minus Q negative A over 2. Just to show you what this means, the best response of A to QB, QC, QD is 650 minus QA, sorry, not QA, QB plus QC plus QD divided by 2. These mean the same thing. Okay, so we could do this for all of the other firms, but I'm just gonna claim that the best response functions are gonna be exactly the same because firms have the same cost functions and they have the same, they all face the same price. So we have B R B to Q negative B, 650 minus Q negative B divided by 2, BRC to Q negative C, 650 minus Q negative C divided by 2, and finally BRD Q negative D is 650 minus Q negative D divided by 2. Okay, so we did this. We get the same thing for each of these. Okay. So what we're going to do is we're going to recognize that each of these best response functions is exactly the same. So each firm is going to produce the total industry output divided by 4. They'll split the market evenly because their best response functions are identical. So this means QA is Q divided by 4. Q negative A is 3, well, yeah, so it's 3/4 times Q. Okay, so what I'm going to do is I'm going to solve for the function of Q, which makes this a firm A's best response. Okay, so what I'm doing is I'm saying, all right, I've conjectured that this is the equilibrium quantity of firm A, and that this is the equilibrium quantity of the other firms added together. So I need for this to be a best response to the added together quantities of other firms. So I'm just going to use my best response function to find what Q has to be. So I get Q divided by 4. It's going to be 650 minus 3/4 Q divided by 2. Because again, I just plug this into the best response function. So it's going to be 650 minus the sum of the quantities of the other firms divided by 2. So that's what I do here. So I get Q divided by 4 is equal to 650 minus 3 divided by 8Q. So this means I have 2Q divided by 8 plus 3Q divided by 8, just moving this over to the other side. This is equal to 650. So I get 5Q over 8, 650. And this means Q is 650 divided by 5 times 8. Now 650 divided by 5 is 1. So it's going to be 130 times 8. That's going to be 800 plus 240, so it's, I think, 1040. Just gotta check my math there. 650 times 8 divided by 5. Oh yeah. Sorry. You know, every mental math win is a big win. Okay, so this is the total industry quantity. Okay. And now all we're going to do is we're going to have QA star is QB star, because the firms split the market evenly. So each of them is going to be 1/4 of the total. So each of them is 1040 divided by 4, which is 250 plus 10. So it's going to be 260, I think. Again, I'm going to check that. Oh yeah, okay. We are on a roll. So the market price is going to be, I forgot what it was. 75 minus the sum of the quantities divided by 20. Okay. So 75 minus 1040 divided by 20. 20 times 50 is 1,000. 20 times 2 is 4. So it's going to be 75 minus 22. Okay, so 52, I think. Yeah, 23. Okay, sweet. I don't know. I think these are fun. I'm biased because, this is what I do for a living, but, I think they're fun. So the last thing is we need to find the margin. So here we're going to find price minus marginal cost divided by price. So this is going to be 23 minus 10 divided by 23. This gives us 13 over 23. This is approximately like 56%, which is lower. Why is this lower? More firms, so there's more competition. Just a fun fact, as the number of firms goes to infinity, we have price goes to marginal cost. That's just a little fun fact about competition. You could do this game, instead of having 4 people, you just have n people, and you would see that the price goes down to marginal cost. It's really cool. Okay, so now for the last problem, the last review problem, we're going to have, just going to go back up and just bring that down. Hello, okay. So we're going to have 2 separate demand functions for each firm. So we have QA is 800 minus 25 PA plus 10 PB. Similarly, QB is 800 minus 25 PB plus 10 PA. Okay, so each firm has a different demand function. This is a differentiated Bertrand game. And what we're going to do here is we're going to assume firms compete in quantity, firms compete in prices. But one thing that's important to note here is it's not like the homogeneous good Bertrand case, where there was no differentiation between the firms. Here, firms are selling slightly different products. There's going to be some degree of differentiation between these, and they're not perfect substitutes. So consumers are going to pick the one, it's not just them going to be picking the ones which cheapest. Sorry, I'm a bit tired. They're not just going to be picking the cheapest one, they're going to be picking the one which they also like more, and of course they take into account the price, but it's not going to be the only deciding factor. So here, it's not as how do I want to say this? It's not okay. So firms are choosing prices. We need to find what their profit functions are. So the profit of firm A, we're setting prices PA, and from firm B, setting prices for PB is going to be 800 minus 25 PA plus 10 PB times PA. We're going to subtract, so just getting ahead of myself here, this is QA. This is PA minus 10, because this is their marginal cost, times the quantity. So it's going to be, again, 800 minus 25 PA plus 10 PB. So this is QA. I'm just going to write this out. I'm going to factor it. 800 PA minus 25 PA squared plus 10 PA PB minus 8,000 plus 250 PA minus 100 PB. Okay, so This is our profit function for firm A. I'm going to consolidate this. This is 1050 PA minus 25 PA squared plus 10 PA PB minus 800 minus 8,000 minus 100 PB. Okay, so I want to find the maximum of this with respect to PA. So I'm going to take the derivative with respect to PA. This will give me 1,500. Oh my goodness, 1,050. I need more sleep. Minus 50 PA plus 10 PB is equal to 0. Okay, so I'll set this equal to 0 and I will solve for PA. So 50 PA is equal to 1,050 plus 10 PB. And this will get me PA equal to 1050 divided by, sorry, my pencil is like bad. 1050 divided by 50 plus 10 divided by 50 times PB. So sorry for being a mess here. It's 21 plus PB over 5. So the best response of firm A to the price PB is 21 plus PB divided by 5. Now, the demand structure for firm B is identical. We see it's going to be minus 25 times their own price, but 10 plus 10 times the price of their competitor. This is exactly the same thing as A's. It's just I switched the PBs and the BAs. Furthermore, the cost function for each firm is the same. They just have a marginal cost of 10. So the profit function is going to be very, very similar. I'm just going to write it out without doing all the steps. You can certainly try it if you want, but we're just going to find it's the same thing. Okay, so that's the profit function for firm B. We'll have a very similar derivative. We'll get the same best response function. We just interchange the indices. Okay, so that is the best response of B to whatever price firm A sets. As before, we want to plug one of these into the other. Okay, so I'm going to plug B into A. You don't have to do it this way. It doesn't matter. I'm just going to do it that way. You could plug A into B. It's your choice, dealer's choice. So we must have that PA star in equilibrium is the best response of firm A to the price set by firm B. So it's going to be 21 plus PB over 5. And then firm B has to be playing 21 plus PA star divided by 5. Again, this is best response of firm B. And this whole thing is the best response of firm A. I don't know if it's helpful for me to illustrate it like this, but this is the best response of A. This is the best response of B. Okay, so I'm just going to solve this for PA star. PA star is 21 plus 21 over 5 plus PA star over 25. I'm going to subtract this over to the other side. So I get 24 over 25 PA star. So you go to 21 plus 21 over 5. So just multiplying this out. What I'm going to do is I'm going to simplify this right-hand side. So this is going to be 21 times 1 plus 1/5. So it's 21 times 6/5. So now I'm ready to multiply by the reciprocal. So I'm just going to multiply by 25 over 24 to get rid of this fraction and move it over to the other side. So I get PA star is 21 times 6 over 5 times 25 over 24. And I did it this way so that we can get some nice cancellation. So PA star is equal to 21. I'm going to group these. It's 25 over 5 plus 6 over 24. I know I'm showing a lot of steps. I feel it's better to show too many steps than too little. So this is 21 times 5 divided by 4, because 25 divided by 5 is 5. This is 1, and 6 divided by 24 is 1/4. So this ends up being 5 over 4. At long last, this is 105 over 4. It's not the nicest thing, but it's equal to 26.25. Okay, so I know that was a lot of algebra. I'm going to use this to solve for PB star. It's going to be the same thing. Spoiler alert. So PB star is 21 plus PA star divided by 5. So it's going to be, I'm going to use the fraction form. So it's 105. Well, okay, I'll just write 26.25 divided by 5. And this will equal 26.25. Fun fact. Now we need to find the equilibrium quantities. So QA star is going to be 800 minus that's 25 PA plus 10 PB, which is also 26.25. So it's 800 minus 15 times 26.25. And this will be like 406.25. Just sparing you the algebra. We'll find QB star it's going to be the same thing. It's 406.25. You can go through and verify, but it's going to be the same because the prices are the same and the demand structure is the same. Okay. And then finally, we want to find the margin. So we're going to do the same formula that we did before. Oh, I just realized the question asked for the total quantity. So the total industry quantity is Q star is 406.25 plus 406.25. So this is 812.5, I think. Yeah. And then finally, margins. It's price minus marginal cost divided by price. So this is 26.25 minus 10 divided by 26.25. That's going to be 16.25 divided by 26.25. Roughly, I want to say 60%. Yeah, okay, yeah, so it's like 62%. Okay, so a little bit higher than the Cournot case. The idea is we have these demand functions, find the profit based on those demand functions, find the derivative with respect to the firm's price, set that derivative equal to 0. That'll give us a best response function. Do it for the other firm, get a different best response function. To solve this, to find the equilibrium, you plug one best response into the other. I like to color code it, but you don't have to. You get this, and you get an equation that you can solve for PA star. There's a bit of a tedious algebra, and you get this quantity. You get this price. Then, this is the equilibrium price for firm A. And you want to plug that into the best response for firm B to get the equilibrium price for firm B. And we found that the prices are 26.25 for each firm. And then we have prices, we can now find quantities. So given these prices, we just compute what the quantities are. And these are the equilibrium quantities for each firm. So these are things that you always want to report. So you always want to report your equilibrium findings. So like the equilibrium prices, equilibrium quantities. Just read the problem and make sure that you give it what it asks you to answer. And finally, if we wanted to find the total industry quantity, we would just add those together. And then the margins are going to be 62%. All right, thank you so much for following along. I've really enjoyed teaching for you this semester, and I hope you all do great and have a great rest of your semester and a great break. All right, thanks.